I'm Anil Kumar sharing with you a test question on polynomial graphs. Sketch the graph of function f of x equals to 4x cubed minus 8x squared minus 3x plus 9. Describe the characteristics. I'll take this opportunity to explain few other things which you might like to review before sketching the graph and explaining its characteristics. To begin with, we are given a cubic function. We should be in a position to factor this one, and to factor, what values can we try? So let's look into possible factors. Possible factors are ratios of factors of 9, which is a constant, and factors of 4. So let's list all the factors of 9. For example, plus minus 1, plus minus 3, plus minus 9. And then we'll divide each one of these with the factors of 4. So we have plus minus 1, which is already taken care of. So the other factor is 2. So we'll say 2. And the factor of 4 is 4. So first we'll do half of all these. We have plus minus 3 over 2, plus minus 9 over 2. The second factor is 4, so let's do all these divided by 4. So we have plus minus 1 over 4, plus minus 3 over 4, plus minus 9 over 4. Now, okay, so so these are all the possible values which could have been, which might lead to help us factorize. Now the idea is, to begin with, we have to try with these one by one. The list is very long. So let's try with 1, for example. So if I try with 1, so we get, let's call this, f of 1 equals to 1. So if I substitute 1 for x, I get 4 minus 8 minus 3 plus 9. And 8 minus 3 is 11, and that is 13, which is not equal to 0. So 1 is not a factor. So let us try f of minus 1. Minus 1 will result into minus 4, and this becomes positive here, so minus 8. Minus 1 will make this positive, so plus 3 plus 9, and that is equal to 0. So that gives you a possible factor. So x minus 1, x minus minus 1, which makes it x plus 1, is a factor. Now this factor helps us to get others. So we can do long division or synthetic division to move forward from here. So since the space is limited for me, I'll go with synthetic division. So let's do it. Some of you who haven't learned synthetic division, they can divide the polynomial by x plus 1 and get a quadratic equation in the numerator which can be factored. We'll get the same equation. Okay. So let's write down the coefficients. The coefficients are 4, minus 8, minus 3, and 9, right? And what makes this factor 0? Minus 1. So minus 1. The process, as you know, is bring down the leading coefficient, multiply by minus 1, write it there, so we get minus 4, add them up, minus 12, multiply, so we get plus 12, add them up, so we get 9, multiply, get minus 9, and as expected, you get 0 as your remainder. So that's the remainder. So the process is, you have to multiply and then place it there, and when you go down, you have to add. So this is times, right? This is times. Now what you get is the quotient. Of course, that has to be of degree 2. You are dividing cubic function with a linear function, right? So we can write down the coefficients of this function as 4x squared minus 12x plus 9. Now 4x squared minus 12x plus 9 can be factored. It is actually a perfect square, 2x minus 3 whole square, right? 2x minus 3 whole square. So we have factored the given function completely, right? So now let's begin with the factored form of our function. So what do we have here is a function f of x, which could be written as x plus 1 times 2x minus 3 whole square, right? So that becomes the factored form of the function. And here we have two types of zeros. So this leads to, let me write here, a 0, which is at 3 over 2 or 1.5. And what is the order of this 0? 2, right? So you can say order 2 or multiplicity 2. That one is a linear 0, correct? Now since we know the type of zeros, we can actually sketch the graph of this function. Okay, so let's sketch the graph of the function now. We'll make a rough sketch. Okay. So to make a sketch, we already know a couple of things which are very important. First, to begin with, zeros, right? Or 0 is better because with 0 we are giving linear multiplicity also. Intercepts do not really define that. So one is at x equals to minus 1. The other one is at x equals to 3 over 2 or 1.5. The order of this is linear, and this is order 2, this is order 1, correct? Minus 1 and this is 1.5 positive. So let us say that is minus 1 for us. And this, let me not go that far, okay, 1.5 for us, okay. Now, leading coefficient is 4, so an, let me say, is actually positive, is greater than 0, which is 4. And therefore, we can define the end behavior. What is the end behavior? End behavior is a cubic function, degree 3. Let's write degree 3, which means odd. So the end behavior is right side up. Let's write down here, right side up, right, and opposite ends. Is it okay? So the end behavior is when x approaches negative infinity, y approaches negative infinity, and when x approaches positive infinity, y approaches positive infinity, as shown there, right? Now, since this is linear, the graph is going to cross as a straight line, and here it is going to bounce back. Order is 2. Now with that, you can always sketch the graph, but it's better to find the y-intercept. So let's find y-intercept, that is the value when x is 0. So if I substitute 0 in my equation, I get 9. So y-intercept, this is your y-intercept. Okay, so I think that is just enough to sketch a fairly accurate graph. So let's connect. So I start from this end because I want to make this like a smooth curve. Is it okay? And then we can always come back, look at the point, and then go like this. Is it okay? Does it make sense? So that becomes the graph for the given function, and mark the point y-intercept, which is very important. That completes the job. So it's not a big deal. What you need to really do is follow the steps to get to the graph. Now at times we could ask you different types of questions based on the graph. That is increasing, decreasing intervals. When is it positive? When is it negative? and things like that, correct? So I'd like you to, from the given graph, you can write down when is the function greater than equal to 0, that is positive. When is the function less than 0, that is negative, right? However, to find increasing decreasing interval, we'll have to find this point, which is not easy with the given calculations, right? To find increasing decreasing interval, we may have to find this point. However, to be on the safe side, you could always say it is increasing from 1.5 to infinity, and it's also increasing from minus infinity to at least 0, we are sure of, right? At least 0, correct? So that is how actually you can answer many questions related to the given polynomial, right? I hope that helps. So here we'll wind it up and let's move on to the next question. Feel free to write down your suggestions and post questions. Thank you and all the best.